Okay, so this is AMC 8 2025, and the way we're going to do it is we're going to discuss these problems, and at some junctures we may ask you questions about how you think we should proceed. At that time, feel free to stop the video, think through it, and then look at what we are suggesting. Now again, with almost all problems, there are multiple ways of solving them. So what we are going to share is most of the time, one of the ways that we have solved it, you may have a different way of solving, which is excellent. So the first question, usually, AMC 8 goes in an increasing order of complexity. So the first few questions are usually the simplest. But again, we see a lot of students making a mistake in simple questions because they tend to become a bit, relaxed when they see easy questions. So we suggest a lot of mental training or test taking, where you treat every question, no matter how simple or difficult it is, with a lot of attention. So let's look at this one. The 8-pointed star shown in the figure below is a popular quilting pattern. What percent of the entire 4x4 grid is covered by the star? Now, as you can see, the part that is not covered is less. So if you look at the yellow highlighted portions, they are less than the portions that are covered by the star, right? So if we assume that each block is 1 by 1, then the area of this entire square is 4 times 4 is 16. And the parts that are not covered, if I can, if you count 1 for a full square, half for a half square, so you got 1, 2, 3, 4, 5, 6, 7, and 8. So 8 of 8 square units of the square is covered. That means 8 is not covered. So the portion that is covered is exactly half, which is 50%. Let's look at the second question. The table below shows the ancient hieroglyphics that were used to represent different numbers, all of that. For example, the number 32 was represented by 3 horseshoes and then 2 vertical bars. So 3 horseshoes, 3 times 10, and then 2 times 1, 32. What number was represented by the following combination of hieroglyphics? So I can start from, essentially this side, which is, 3, then I got 2 horseshoes, so 20, and I got 4 hundreds, so that's 400, and then one of the 10,000s. So so this looks like the answer choice, which is B. So in the earlier questions, because they're simple, we have to get it right, but we also have to do it faster so that we're able to save time that we apply to later questions, which are usually more challenging. So let's look at this. So whatever that is, Buffalo something something is a card game in which all the cards are distributed evenly among all players at the start of the game. When Annika and 3 of her friends, so that's a total of 4 people, right? Annika and 3. And again, we won't be, in an actual test, I won't be writing all of this stuff. I'll be doing a lot of it very quickly. So Annika and 3 of her friends play that game. Each player is dealt 15 cards, so a total of 60 cards. Suppose 2 more friends join the game. How many cards will be dealt to each player? So we had 4 people initially, 4 times 15, as we said, 60 cards total. 2 more joined, so now we have 6 people. So the number of cards, how many cards will be dealt to each player is 60 divided by 6 is 10. Now, all of this that we did is probably you can solve this in like 15 seconds. Essentially, you have to go very quickly from here to here to here and to here, right? And that's a mental conditioning you need to do. But, I took a longer time because I was talking, writing, all that stuff, but this can be solved in 15 or even 10 seconds, possibly. All right, look at this. We are counting backwards by 7. First three numbers are 193, 86. What is the 10th number? And I've seen a few people make mistakes on this question, and usually what happens is, when you're finding the 10th number, you sometimes end up calculating either the 11th number or the 9th number because you're not keeping an accurate count of what number you're calculating, right? So you can build an arithmetic progression out of this, and that would be, first term is 100, common difference is 7, d equals 7. So what is the 10th number? So Tn is, the formula a plus n minus 1 times d, which is 100, and common difference is minus 7, sorry. So 100 plus 9 times minus 7, so 10 minus 1. See, I'm double checking whether I'm doing it correctly or not. 10 minus 1, 9, d is minus 7. So 100 minus 63, which is 37. So the answer should be B. Now, if you're not familiar with arithmetic progressions, you can simply manually do it, right? You just have to be good at subtracting 7. You got 100, 93, 86, minus 7 is 79. You just got to be careful when you're subtracting by 7, you're doing it properly, right? So you can go and manually do it. It's going to be a little longer, but you'll get the answer. If you know sequences, arithmetic sequences, then obviously it becomes a little faster. But ask yourself, if you got this wrong, why did you get this wrong? And I'm willing to bet that if you got it wrong, you either chose this or this, which is, either 7 less or 7 more than the correct answer. All right, so let's look at this. This is about Betty, who's driving a truck to deliver packages, and Betty starts at F here. Then she goes to A, then she goes to B, then she goes to C, and then she has to come back to F, right? Returning to F. It's asking what is the shortest distance in blocks she can drive to complete the route. So let me post the answer choices here. Now, there's multiple ways. Now, we need the shortest distance, right? So sometimes we might, and this is a fine approach, we just draw the route. And because they're like rectangles, it doesn't matter, like, for example, if I go from here to here or go from here to there, right? They're both 2 units long. So I'm just going to go here. And as I'm drawing, and you could have drawn this on the question sheet with your pencil and counted while you went along. So I'll call this a slightly longer approach, not terribly long, and then we'll talk about maybe a simpler approach to do this, right? But again, in the testing scenario, sometimes a simpler approach doesn't immediately come to us. So questions like these, doesn't take that long to just manually draw and figure this out. So I'm going to count while I'm drawing. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, oops. I messed up the drawing a little bit. Let me see if I can, if not, I'll restart. So it assumed that I'm drawing a rectangle. Okay, let's start again. So I'm going to draw it again. So I got 1, 2, 3, 4, 5. Let me change color. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. Right? So, and this looks to be the shortest route. And again, the shortest route won't change. For example, if I were to choose to go here and go that way, it will still be the same length route, right? So that gives us an idea. Essentially, what we are looking for is the perimeter of this rectangle. Right, so let's count the perimeter. So what this does, I don't have to like manually draw all those paths. I can visualize that that perimeter is essentially going to be my shortest route. So this side is 1, 2, 3, 4, 5. This side is 1, 2, 3, 4, 5, 6, 7. Right, so 5 plus 7 is 12. 12 times 2 is 24. Okay, so that is a slightly faster way to do it. Now again, the way we did it first is not terribly long. So ask yourself, if you got this wrong, where I'm guessing it's probably because when you were counting, and let's say you were counting without drawing, that may be a place where you make a mistake. So let me illustrate that a little bit. So imagine I'm counting without drawing these lines, right? I'm kind of mentally looking at those. So currently I'm going to do physical drawing, but assume that I'm not actually drawing it. I'm doing that in my mind, right? So the mistake that might happen is something like this, like, okay, 1, 2, then I forget to count this one and then go here, here, here. Or, there's too many lines here. I forget to do this. I go there, right? So either, find a shorter strategy like the perimeter one, or actually, draw on the paper test that you have and do it that way. Chances of mistakes are very, very minimal if you actually draw it out. And if any of you have a faster way of doing any of the problems, feel free to post your solution as a response under the YouTube video. We would love to hear about that, and I'm sure your colleagues and peers would love to hear about that as well. Okay, let's look at question 6. Okay, so we have these 5 numbers, and the question says he erases one of the numbers, and the sum of the remaining 4 numbers is a multiple of 4. Right, so there could be a few different ways of doing it. One of the things we could do, let's add up. So there's like sequential numbers. So we know that it's going to be, so the average is 17. So 17 times 5, the sum is going to be 85. Right, sum is going to be 85. And then you can potentially manually subtract all the numbers and see which one gives you a multiple of 4. We know that it cannot be an even number because that would give us an odd number. Like if I subtract 16, I get 69, right? Yeah, I get 69. And that's an odd number, which can never be a multiple of 4. So I can immediately eliminate 16 and 18. So that essentially leaves 15, 17, or 19. And if you try them one by one, like if I subtract 15, I get 70. If I subtract 17, I get 68. And I can see that this is already a multiple of 4. This is 17 times 4. Right? So I know that the answer is 17. But again, if we were not lucky and it was not 17, you'll just have to try one more number. You can also use modular arithmetic to figure that out. Like 85 is 1 mod 4. So essentially, the number that you're going to subtract should be also plus 1 mod 4, right? Because then if you subtract, you're going to get 0 mod 4. And 17 is the only number that is 1 mod 4. Okay, so if you're not familiar with modular arithmetic, then don't worry about it. But you can use modular arithmetic to figure this solution out faster, a little bit faster. All right, let's go to question 7. So on the most recent exam in that professor's class, it gives you 5 students earned a score of at least 95%, 13 earned a score of at least 90%, so on and so forth. Now, what you can imagine is the 13 students who earned a score of at least 90 includes this 5, right? So now let's look at the question. How many students earned a score of at least 80% and less than 90? That means 90 is not included. So that is excluded, right? So because I know that 13 of them earned a score at least 90, meaning 90 or higher. So all I do is I subtract 13 from 50 and I get 37. Okay, fairly simple. In fact, if I wasn't talking that much, writing that much, this is probably call it a 5 to 7 second question. Okay, let's think about this one. Okay, so we have a cardboard cube, like a box, right? And Isaiah cuts open that along its edges to form the flat shape as shown. This is a flat shape, right? And this has an area of 18 square centimeters. What is the volume of this cube? Now, one way I can do this, it says 18, I count the number of squares, right? 1, 2, 3, 4, 5, 6, right? That means each square has an area of 3, and because it's a cube, each side is equal, so each side is square root of 3, right? Essentially the same concept, but if you recall, surface area of a cube is 6a squared, and this is how we know it, right? That's how we get 18. Is 6 of those squares add up to 18. So we are essentially doing the same thing, but by utilizing the kind of concept slash formula that we might remember, right? 6a squared equals 18. So a gives us square root of 3. The volume is a cubed, which is 3 root 3, right? Again, a roughly 5 to 7 second question. So if you were to think so far, like 8 questions we have done, right? All of them, let's be a bit conservative, let's call them 15 seconds per question, right? Because we want to be a little bit careful we're not making mistakes, so call it a 15 second per question. We are still only at 120 seconds, 2 minutes, right? So plenty of time left. So that's the importance of speed in approaching the earlier questions and doing them faster. Okay, let's see what we can figure out about question 9. So we have a clock, and it says that this person looks at 6 pairs of numbers directly across from each other, for example, 1 and 7. Then she takes the average of each of those pairs, right? So this average becomes 4, this average becomes 6, and then let's say this average becomes 8, and then this average becomes 9, right? And then she takes the average of the resulting 6 numbers. Okay, so the slightly longer way to do it would be for me to look at all the averages. I can see that it starts from 4 and goes all the way up to 9, right? So this is 6 numbers. So I can essentially add up those numbers and then divide by 6, right? So 4 plus 5 plus 6 plus 7 plus 8 plus 9, and then divide by 6, which would give me what, 9, 15, 22, 30, 39 over 6. And I'm not even going to divide. This is the only one that has a decimal, and I know 39 over 6 is going to give me a decimal. But I can really see that it's going to be 6.5, right? So that is one way to do it. The other way is to, again, not much faster than this, but maybe a tad bit more elegant and more fast, is that essentially what we're doing is we're adding all the numbers, because what I'm doing is I'm doing 1 plus 7 divided by 2. Then I am doing 2 plus 8 divided by 2, plus so on and so forth. So essentially, if I group the numerators together, I'm adding all the numbers up to 12 and then dividing by 2. And I know the easy way to do this, which is 12 times 13 divided by 2. It's a sum of the first n natural numbers, n times n plus 1 divided by 2. This gives me 78. Sorry, this divided by 2 is also here. So 78 by 2, this is 39. And then because it results in 6 numbers, I need to divide that by 6, and I'm going to get 6.5, right? So this approach is maybe a tad bit faster, but again, not this. The initial approach that we took is not terribly long either, right? Maybe the first approach can be done in maybe 20 seconds to 30 seconds. This one maybe 15 to 20 seconds, something like that. Okay, let's look at question 10. Okay, so we have a rectangle with side lengths AB is 5 and AD is 3. And that rectangle is rotated 90 degrees clockwise around the midpoint, since this is the midpoint of side DC. Okay, so that gives us, this is 2.5, this is 2.5, right? And this is 3, this is 5. To give a second rectangle, what is the total area in square inches covered by the two overlapping rectangles? So keep in mind, it's a total area they're asking for. They're not asking for the common area between the two, right? And that's one area where I feel some students might have misinterpreted the question by not reading it close enough. They're not asking for the overlapping area, which would have been this yellow portion. They're asking for the total area, right? So we know that the area of the rectangle ABCD is essentially 15, right? So the first thing I'm going to do, I'm going to 15 times 2, the total area of two rectangles, ignoring the overlap. So I get 30. Now that 30 double counts this yellow portion, right? Because I'm counting it for the horizontal one and the vertical one 2 times. So then essentially what we need to do is we need to figure out the area of that yellow portion and subtract it, right? So I got this length as 2.5, and because it's the midpoint, so this is also 2.5, right? So the area of this yellow portion becomes 2.5 times 2.5. We recall that 25 times 25 is 625. So this is going to be 6.25. So you subtract that from there, and you get 23.75, right? D is the answer. So again, fairly straightforward question. If I'm not talking as much and writing as much, this is, let's conservatively give it, because I have a decimal multiplication, I want to make sure that I don't make a mistake there. Probably conservatively 30 seconds, but doable in 20. Okay, doable in 20 seconds. So again, if I were to be conservative here, up to 10 questions, 20 seconds times 10, again, I'm being a bit generous to myself. That's 200 seconds, right? Which is a little more than 3 minutes, 3 minutes, 20 seconds. So that's kind of the speed that I like to be in, because that saves me enough time that I can dedicate for later questions that are going to be harder. Okay, so this question tells us that tetromino consists of 4 squares connected along their edges. There are 5 possible tetromino shapes, as you see here, which can be rotated or flipped over. And then it says 3 tetrominos are used to completely cover over a 3 by 4 rectangle that you see here. Okay, 3 by 4 rectangle. At least one of the tiles is an S tile. What are the other 2 tiles? So let me make this picture a little bigger. And my first approach here was to consider this. So the S tile is, it has, it has 4 squares. So I was trying to see, where I could place it. My mind went here, but then if I do that, I get a 1 square that is isolated that I cannot fill. So it's got to be placed somehow differently. So that brought me to this type of a possible configuration, right? And then, as you can see, we get two possible L tiles. No, not two L, sorry, yeah, my mistake. This only goes up to here, right? This only goes up to here, the L tile, right? It only goes up to here. And then I put another L tile that covers this. So I can do this with two L's, and that's option C. Okay, let's make this slightly bigger. So the region has 24 squares, each with side length 1 centimeter. What is the area in square centimeters of the largest circle that can fit inside the region, possibly touching the boundaries? It can touch the boundaries, it cannot exceed the boundary, right? So the shape is pretty symmetrical, so I'm going to assume that the center of the circle is going to be here. And intuitively, you know, I'm going to experiment with like this being the radius, right? If this would be the radius, you know, part of the circle will go outside the square. So I'm looking at the furthest intersection that will keep the intersection, meaning like point like this, that'll keep the circle inside the boundary, right? So if I were to draw a circle that way, it's going to become something like this. Something like this. And that keeps it inside the boundaries. So just quickly visualizing, check if there's any other circle that might work. As soon as I go beyond this point, it's going to cross the boundaries. I can't do that, right? So this is the furthest boundary that I can touch. So it seems to be fine. Now this distance, this is 1, this is 1, this is 1, right? So using Pythagorean, 2 squared plus 1 squared, which is square root of 5. So that's my radius. So area is pi r squared, which is going to be 5 pi. Okay, in questions like these, it's worth spending a few seconds just to examine that, hey, have I missed a possibility of a bigger radius, which is what we did. In my opinion, it's a worthwhile use of time. But again, please feel free to make your own calls. You know, you will know whether you make these decisions very accurately in problems like these. Okay, let's look at question 13. Okay, so we are dealing with even numbers and remainders when divided by 7. So, and then we have a histogram that, you know, remainder on the x-axis and number of times we get that remainder, right? So one of the approaches that intuitively would come to our mind to try the first is try to develop a pattern, and we can do that. I think that's a fine approach to do. If I, you know, write down all the even numbers, 2, 4, 6, some of them at least, 10, 12, 14, 16. So let's look at the remainders that we get. So the remainders are going to be 2, 4, 6, 1, 3, 5, 0. Okay, then again it starts 2. Sorry, change color. 18, 4. And the pattern will continue, right? So if we were to see, the pattern is 2, 4, 6, 1, 3, 5, 0, right? So this is where the pattern sort of recycles, right? 2, 4, 6, 1, 3, 5, 0. And then again, 2, 4, 6, 1, 3, 5, 0. So one of the approaches we could do is 50 we know is remainder 1. So, you know, we know that it's going to repeat the pattern, and then it's going to end with 2, 4, 6, 1, right? So we have a certain number of complete patterns of, 7 options, And then it ends in 2461 because 50 is remainder 1. So we know that it ends in remainder 1, which means it has to go 2461. Right? So there's a couple ways we can do this. So we say, okay, I have, how many numbers do I have from 2 to 50? It is 25 numbers. Right? 25 numbers. So you divide 25 by 7. So you get 3 and change, right? 3 and remainder 4. So these remainder 4 are essentially these, right? That means this pattern gets repeated 3 times, okay? And then I have these additional ones, which means if I look at my remainders 2, 4, 6, and 1, I should be getting 4 each. So let's see if that helps us narrow down our options. So essentially, any option that does not have 4 each of these remainders, 2, 4, 6, and 1, we're going to discard that. Right? So this one, okay, 1, there's 3. So discard that. 2, also here, 2, the remainder of 2 has 3 entries or 3 number of times. Right? So discard that. Let's see, let's examine this one, 2, 4, 6, 1, 4, 6. Okay, 6 has 3, so discard that. This one, 4 has 3, discard that. So this should be the correct answer. And look at that, 1, 2, 4, and 6. They all have 4 entries for those respective remainders. And that's how we can narrow down our answer as A, right? So this is a fairly simple application of developing a pattern of remainders like you see on the right hand side. And that essentially leads us to how to eliminate incorrect options and figure out which one's the right one. And of course, instead of eliminating, you can, if you are able to eyeball and quickly identify that, okay, what, answer A has what we need, which is this. That's obviously faster. You don't have to go through the other eliminations that we did, right? But I think the strategy holds. It's a fairly decent strategy, not too long. So look at question 14. Okay, so what we see here is we are given 5 numbers and they're arranged in increasing order, which is good. We don't have to rearrange them. It says a number n is inserted into that list somewhere. It doesn't tell you where you insert it. Then it tells you that the mean after inserting is twice as great as the median, right? What is n? Now look at this. We have 5 numbers. So 5, we take the middle one for median, which is 7. Now, because the mean is going to be greater than the median, we kind of have a sense that we are likely looking at a number greater than 7, meaning the number is going to be entered somewhere to the right of that median, right? Somewhere to the right of that median. Now, wherever we, call it A, B, and C, wherever we enter that number, our new median is going to be the average of these two, which is still 7, right? That's still going to be 7. So my median is still 7, which means my mean is 14. And that, lends us a very simple solution to this problem. I essentially add the numbers up. So I get 8, 15, 22, 50. So 50 plus n divided by, we now have 6 numbers, is 14. So that gives me n is equal to 34. Right? Fairly fast. So even up to like question 14, if I were to increase my average time a little, conservatively speaking, so let's say instead of 30 seconds, what did I assume last? 20 or 30? Let me see. I assume 30 seconds. So let's make it 40 now, right? Again, we are being conservative. You can do it in much less than that. But 40 seconds times 14 questions, which is 560 seconds. What is that? It's a little less than 10 minutes, right, which is 9 minutes and 20 seconds. Okay, still, we have a total of 40 minutes on the contest, and we are very close to just like 25%, and we have covered more than half the questions. So that's a very good time ratio. So up to question 14 to be like under 10 minutes, that's a good time zone to be in. Okay, so here there's a 6x6 grid, and that person colors 13 of the unit squares silver, and the remaining, meaning, so total 6x6 gives me 36 squares, right? If 13 are colored silver, that leaves me 23 squares that are colored gold, right? And then we fold the grid in half vertically. It shows us the dotted line where we fold, forming pairs of overlapping unit squares. Let small m and capital M equal the least and the greatest possible number of gold on gold pairs. What is the value of small m plus capital M? So let's tackle the least one first, right? So to do the least one, the simplest thing I could do is color this entire portion gold. So that way I'm minimizing overlap, right? Every square I have on one side, meaning I have that few of them to overlap with those squares, right? So this is 6 times 3 is 18, right? 18 squares. And then, it doesn't matter if you color any of the 5s, because I need a total of 23, right? You color any of the 5s golden. So essentially then you're limiting the overlap to these 5 squares. Right? So pause and think about if you feel there's a way to get a smaller value for small m, but I think there isn't. So small m will be 5. So we have 5 squares like these 5, and it doesn't matter how you place the 5 on the right hand side, you're going to get 5 squares of overlap. Okay, again, feel free to pause the video and see if you want to experiment with a couple other options, see if that plays out. And once you're convinced, replay the video to look at getting to capital M. So for capital M, I want the greatest possible overlaps, meaning to the degree I can, I'm going to try and have a fairly even distribution on either side, right? Because I want to have as many overlaps as I can. Now, obviously 23 is an odd number, so I can't have, half a square on each side. So what I'm going to do is forget one of the squares, so that leaves me with 22. So that lets me color 11 on both sides, right? So 3 to 6, and then it doesn't matter how you color the 11. You just have to make sure that on the opposite side you are symmetrical, so that when you fold, you get overlap on all those 11 squares, right? So this currently has 11 squares overlapping, right? And the 23rd square, wherever you put, it doesn't matter because that's not going to overlap. So our capital M is 11. Now again, feel free to pause the video, do some different types of coloring and see if you can get to a number greater than 11. We don't think it's possible. So, but again, you should try if you would like. So then if I add the 2, 11 plus 5, I get 16, which is answer choice C. Let's look at question 16. All right, so this states that we are choosing 5 distinct integers from 1 to 10 and 5 distinct integers from 11 to 20 such that no two numbers that we choose differ by exactly 10. It means that if 1 and 11 are not allowed to be chosen, right? No two integers differ by exactly 10. I cannot choose 2 and 12. Same way, I cannot choose 7 and 17, right? And it's asking what is the sum of the 10 numbers chosen. Now, for a moment, let's think, quickly, run some things in our mind, and we can see that I can choose the numbers in a few different ways, right? Like I can choose, for example, 1 and 19. I can choose 2 and 13, something like that. But because it is not putting in any other constraints for me, I'm going to assume that no matter how I choose the numbers, as long as I take care of this constraint, my total should not change, right? It is not asking me what is the smallest sum or what is the biggest sum of the 10 chosen numbers. So no matter how I choose the 10, as long as I keep this constraint, yellow highlighted constraint in mind, the sum should be the same. So what I'm going to do is very simply, I'm going to choose 1, 2, 3, 4, 5 from 1 to 10. And from 11 to 20, I know that I cannot choose 11 because I have 1. I cannot choose 15 because I have 5. So I'm going to start from 16, right? And I'm going to choose 16, 17, 18, 19, 20, right? And I quickly double check. Yes, no two numbers differ exactly by 10. So I've satisfied that criteria. And now I can add. Now there's a slightly better way to add than just, going there, adding there, adding there. What I notice is if I add this way, right? If I add 20 and 1, I get 21. 19 and 2, I get 21. So essentially, I get 5 options of 21. So 21 times 5 is 105, okay, which is answer choice C. Now again, a minor thing, you can do the addition the normal way, but I think this is going to save us a few seconds, and we're going to take every second that we can save. Okay, let's think about question 17. All right, seems to be a long question, so we're going to be a bit careful in reading this. So in this land, there are 3 cities, A, B, and C. There are 100 people who live in A, so I'm going to start writing 100, 120, and 160. And students, this is one of the advantages I feel of doing a paper test, where you can actually draw. You already have the paper with you with this question. You don't have to redraw it, which in a digital test, you'll have to draw this picture, or in some, maybe not this picture, but a geometry problem, for example, you have to draw it, right? So that saves you some time in a paper test. I want you to think about that. So, but again, coming back to the problem, so I have 100 people in A, 120 in B, 160 in C, and everyone works in one of the 3 cities, and a person may work in the same city. This is important. A person may work in the same city where they live, right? We sometimes gloss over this. And you'll see why this is important. And one of the common reasons for mistakes in this question is not paying attention to this criteria. In the figure below, an arrow pointing from one city to another is labeled with the fraction of people who live in the first city but work in the second city. For example, 1/4 of the people who live in A work in B, and that's why you see this arrow with 1/4. The question is, how many people work in A? Right, so we got to look for the people moving from different cities to work in A, which is this one and that one, right? So very quickly we can see it's 1/3 times 120 plus 1/8 times 160. Very simple multiplication and division. That gives me 60 total, right? So 60 total are moving into A to work, but we got to keep in mind that a person may work in the same city where they live. So we got to figure out how many people who live in A also work in A, right? So for that, let's look at the people who are moving out of A to work, right? This is a 1/4 and this is a 1/5, right? These are the 2 arrows coming out of city A, right? So I'm going to add them together. So 1/4 plus 1/5, which is 9/20, right? If 9/20 are leaving A, that means 11/20 are staying in A times 100, which is 55. So I need to add these two together to get 115 is the people who are working in A, right? So some students who got this wrong, and look at this, they have the answer choice 60 as one of the options because they know that some people are going to ignore this criteria. They're going to look at 60 and very quickly choose that answer and move on, right? So in long questions like this, I strongly suggest paying attention to the verbiage, meaning the wording of the question, making sure you're not glossing over any part that is really, really important. Okay, so if you got this question wrong, then check if you got like 60 or maybe you got 50. Unlikely you're going to get 55 as one of the wrong answers. If you got this wrong, likely you chose 60. But again, take a look at your individual case. Right? It is as important to analyze mistakes as it is to look at this or look at your overall score. So let's go to question 18, see what that is about. Okay, so the circle shown below on the left has a radius of 1 unit, and the region between the circle and the inscribed square is shaded. Circle shown on the right, only 1/4 of the region between the circle and the inscribed square is shaded, as you can see. The additional information is the shaded regions in the two circles have the same area. What is the radius in units of the circle on the right? Okay, so it gives us, when it says same area, it's kind of hinting at what equation we will have to build, right? Let's call this circle A, circle B. Let's do circle A first. So the shaded area, essentially the difference between the circle area, which is pi times 1 squared, minus the area of this square inside. And if you recall, if I have a square that is the diagonal is, call it D, then the area is half times D times D. And why is that? Because so you can split the square into two triangles. This is one triangle, this is one triangle, right? And area of each triangle is half times D over 2, because this height is half of the diagonal is D over 2. And then because there's two of them, you multiply by 2 and you get half times D, right? So the area of this shaded region in my picture A is pi times 1 squared minus, and keep in mind that my diagonal is 2 units long, not 1. That's another common mistake where we mistake the radius here for the diameter or the diagonal. The diagonal has length 2 units, not 1 unit, right? So the area of the square is half times 2 squared, right? So if I simplify, this becomes pi minus 2. Let's call that expression 1. So the shaded area of A is pi minus 2. Let's do the same with shaded area of B. Keep in mind that this is only 1/4, right? So the shaded area of B, let me first put a 1/4 outside of it so that I don't forget. It's going to be same thing. Area of the circle is pi r squared minus the diagonal is 2r, right? The diagonal length is 2r. So same thing, minus half times 2r squared. And I'm writing more than I would normally when I'm taking a test. So obviously you'll be much faster when you're taking the actual test in this question. So this becomes 1/4 and then pi r squared minus 2r squared, right? So now I can factor out the r squared and I get r squared over 4 times pi minus 2. This is my expression 2. And the question tells us that both the shaded areas have the same area, right? So then I equate the two. So pi minus 2 is equal to r squared over 4 times pi minus 2. And pi is not equal to 2, so you can cancel those and you get r squared equals 4, gives you r equals 2, right? So if I were to not be writing so much, maybe a 45-second question, okay, can be done in 30 or less, but conservatively, let's say this is a 45-second solution. Oh, by the way, on this previous question, if you've gotten a wrong answer, it could be because you did not consider twice the radius to be the diagonal. You took the radius to be equal to the diagonal. Just take a look where you went wrong, right? It is very important to know where and why your mistake happened. Okay. Okay, so this looks like a question of distance, speed, time. And it's a bit long, so let's read it carefully. So I got two towns connected by a straight road, 15 miles long. I see 5, 5, 5. Okay, makes sense. Traveling from town A to town B, the speed limit changes every 5 miles. As I can see, 25, 40, 20. Two cars, one at town A and one at town B, start moving towards each other at the same time. So this car moves that way, this car moves that way. They drive at exactly the speed limit in each portion of the road. How far from town A in miles will the two cars meet? Okay, so if you run some quick calculations of time, you'll figure out that they're going to meet somewhere here in the middle, right, in this segment. Okay, so let's say, because the question says how far from town A, let's assume that they meet here, which is at a distance d miles from this point. They call this point X. Okay, d miles from point X is where they meet, right? So this is their meeting line. Now, because they're meeting, the time that they have been driving is the same. So the car from A has been driving for the same time as the car from that has been starting from B, right? So that is crucial. So if we can figure out the time that A has been traveling up to this point and the time that B has been traveling up to that point and equate them, then it would give us an equation in D which we can solve to get D, right? So that's our going in strategy. So let's start with figuring out this time first for A, right? Now I know that to cover this distance, the first block is going to be, the time to cover that will be, distance divided by speed. So distance is 5 divided by 25 is 1/5 of an hour. Okay, same thing here. To cover this distance will be 5 divided by 20, which is 1/4 of an hour. Okay, now let's see what we can do about this time, the red time. So the red time. Okay, so the red time, we're going d miles at 40 miles per hour, right? So that time is going to be d over 40. Okay, and then let's look at this green time. So for the green time, the distance we are traveling is 5 minus d, because this whole thing is 5 miles and this portion is d miles. So I'm traveling 5 minus d, again at a speed of 40 miles per hour, right? So now I'm going to add all the times and add all the times from the left hand side, equate all the times from the right hand side, right? So the left hand side time is equal to 1/5 of an hour plus the red one, which is d over 40. And the right hand side is 1/4 of an hour plus the green one, which is 5 minus d over 40. Now, to get rid of fractions, let's just multiply by 40 on both sides. So I get 8 plus d equals 10 plus 5 minus d, right? So if I simplify, I get 2d on that side, so 15 minus 8, 7, so I get d equals 3.5, right? And since the question is asking how far from town A do the two cars meet, I just need to add 5 to this, right? So plus 5, which gives me 8.5. That's my answer. Okay, it's a little bit long speed distance calculation. If there's a faster way that any of you did, please post that solution as a comment. As I said, we would love to see quicker, faster solutions. And as you're observing, now the later questions are taking us a little longer to solve. So that is the advantage. If we go fast on the previous questions, we save a lot of time that we can dedicate to the later questions. Okay, so the three people are sharing a large block of cheese. They turns cutting off half of what remains and eating it. So first Sarika eats half of the cheese, then Dave eats half of the remaining half, and then Rajiv eats half of what remains. And then it goes back to Sarika, who again eats half of what's remaining, and so on and so forth. And they stop eating when the cheese is too small to see, right? So they keep on eating until it's like tiny atoms of cheese. Okay, about what fraction of the original block of cheese does Sarika eat in total? Now, if you're familiar with geometric sequences, which is essentially sequences like this: 2, 4, 8, 16, or half, 1/4, 1/8, where each number is a multiple of the previous number. So here you're multiplying by 2. This one you're multiplying by half. So that's a geometric sequence. Now, they keep on eating until the cheese is too small to see. That's a hint that we're looking at an infinite geometric sequence, close to an infinite geometric sequence. So essentially then our task becomes relatively simple. We just figured out how much Sarika is eating, that develop that pattern. Hopefully it's a geometric pattern, and then we figured the solution out, right? So let's look at that. So Sarika first eats half. So I'm going to write Sarika's share in black and use different color for the other two. And then Dave eats half of the remaining. So Dave eats 1/4, and then Rajiv eats half of what's remaining after that. So Rajiv eats 1/8, and then it's back again Sarika's turn, who eats 1/16. And again we keep going, 132, 164. And then again, Sarika, it's 1/28, right? So if we look at that, it's a pattern, and she's essentially eating all of these fractions where the ratio or the multiple is 1/8, right? The multiple between these two is 1/8, 1/8, 1/8. So essentially, if you recall the sum of an infinite geometric sequence with a as the first term, and a times r squared being the other terms, where r is the common ratio, the sum is a over 1 minus r, right? So this becomes a is the first term. Here the first term is half, and then 1 minus r becomes 1 minus 1/8. So this is half divided by 7/8, which is half. We flip multiply in case you get confused. So 2, 4. We get 4/7 of the cheese is what Sarika ends up eating, right? Again, a little bit longer in terms of calculations and the thought process, but not terribly long. You essentially have to make the connection between the clues given in the problem and interpreting them as being a infinite geometric sequence. Right, let's look at question 21. It's about this school that has assigned grades 1 through 7 to pods A through G, 1 grade per pod. Some of the pods are connected by walkways as shown. The school noticed that each pair of connected pods has been assigned grades differing by 2 or more grade levels. For example, grades 1 and 2 will not be in pods directly connected by a walkway because the difference is less than 2. So if 2 pods are connected, the difference has to be either 2 or more, right? And then the question is, what is some of the grade levels assigned to pods C, E, and F? So C, E, and F. So when we look at the picture, what we find is that there are 2 pods that are connected to every other pod except for 1. Look at pods F and C, right? It's connected to every other pod. Actually, we choose a different color. So F is not connected to D, and C is not connected to G, but they're connected to every other pod except those 2 respectively, right? So think, what does that tell us, right? F is connected to every other pod except for D. C is connected to every other pod except for G. right? Which means C and F have to be either 1 or 7. So one of them has to be 1, the other one has to be 7, right? Because that that is the only way, if you consider the edge numbers, is where you're connected to 5 pods and not to one of them. So pause the video and think if that makes sense. So maybe to illustrate that point, just let's digress for a minute. Let's assume for a minute that, okay, F could be 2, right? Now imagine F is connected to every other pod except for one of them, which is D, which means, 2 is next to 1 and next to 3. So one of these here would have to be 1 or 3. Sorry, not D, except for D, like one of these would have to include 1 and 3, and that will not make sense because the pods cannot be connected by a number that is less than 2 apart. So that is why F and C have to be either 1 or 7. So I don't think it matters, but let's try. Let's make this 1. Let's make this 7, right? And the pod that F is not connected to, which is D, right? This is 7. So D will have to be 2, right? D will have to be 2 because that's the only way, F and D are disconnected. And G will have to be 6 because that's the only way that 6 and 7 stay disconnected, right? Now look at this. Because this is D is 2, that means E cannot be 3 or 4, right? Which means 3 or 4 have to be here, like either between A and B, one of them has to be 3, the other one has to be 4. And we'll see if it matters which one is which. But if I'm sorry, no, my mistake. This cannot be 3. This cannot be 3. It can be 4 because 2 plus 2 is 4. Yeah, it can be 4. So, but it cannot be 3, which means one of these has to be 3. Right? One of these has to be 3. What does that tell us? If one of these is 3, that means the other one, let's say this is 3, right? That means this one, B, cannot be 4. Right? It cannot be 4. So whichever one is 3, the other one cannot be 4 because they are connected to each other. What does that tell us? That means this has to be 4. This has to be 4, and then we are done. We just add 7 plus 4 plus 1, we get 12. So feel free to pause the video and think about it for a minute. See if that makes sense. Okay. If you're good with this, let's go and look at question 22. So it says a classroom has a row of 35 hooks, right? And Paulina likes coats to be equally spaced so that there is the same number of empty hooks before the first coat, after the last coat, and between every coat and the next one. So let me draw an example. So let's say these are coats, right? So let's say I draw 3 coats, and I'm going to ignore the number 35 for a minute. So what essentially Paulina likes is that there's got to be the same number of empty hooks before, in between, and at the end. There could be one hook here, one hook here, one hook here, one hook here. So as long as you keep everything the same, that satisfies Paulina's pattern. And then it also tells us that suppose there is at least one coat and at least one empty hook, right? It has to have at least one coat and at least one empty hook, meaning 0 coats are not allowed and 35 coats, all of the hooks are occupied. That is also not allowed, right? So usually, to solve problems like these, I kind of try to draw a certain number of options. Okay, so let's say I have 35 hooks here, and let me just make a case and draw 2 coats, right? 1 coat, 2 coats. So I got three gaps, so to speak, right? The dashes are gaps. Now I had 35 hooks, 2 of them have coats on them, so that leaves me with 33 hooks, right? And I can divide them 11, 11, 11, and that satisfies Paulina's criteria, right? Now let's make up another scenario. Let's consider 3 coats hanging. So I got 1, 2, 3. So 35 minus 3 is 32 hooks remaining. And how many gaps do I have? 1, 2, 3, 4. So notice that the number of gaps is 1 more than the number of coats, right? So 32 divided by 4 becomes 8, and I can satisfy Paulina's criteria again. Now let's consider another case. So let's say we have, I'm trying to see if we're trying to create a case that doesn't work, okay? So let's create, let's move a little more. Let's say 6 coats hanging. 3, 4, 5, 6. Right, I got 6 coats. So the number of free hooks is 35 minus 6 is 29. And it's a prime number, so I already know I won't be able to divide it, but let's see. Right, I got 7 gaps, right? 1, 2, 3, 4, 5, 6, 7 gaps. And 29 over 7 does not give me an integer, which means I will not be able to place equal number of hooks here, 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 and here. So that gives us a strategy that, let's say, I have n coats hanging, right? N coats hanging. This creates n plus 1 gaps. It also creates 35 minus n free hooks, right? So n will work as long as 35 minus n is divisible by n plus 1, right? Pause and think about that. And if you want, rewind and then, think about it again and see if this makes sense. Okay. So now what I can do is I can kind of try to create a table. And 35 is not that big a number. So I think I should be able to manually work out some workable cases. So I got n here. I'm going to do 35 minus n. Actually, let me do n here. Call this n plus 1. 35 minus n. And I'm going to visually see if 35 minus n is divisible by n plus 1. It'll save me some time from adding another column and writing over there. Right? So let's start with n can't be 0. I told you that there has to be at least 1 coat. Right? So 1, 2, 35 minus n is 34. And 34 is divisible by 2, so that works, right? So I'm going to keep on going. So 2, 3, 33 is divisible by 3, that works. 3, 4, 32 is divisible by 4, that works again. 4, 5, 31, not divisible by 5. And 5, 6, 30, divisible by 6. Keep going. 6, we already checked. 29, we know it won't work. Sorry, that is not 29. 6, 7, this is 29. So that won't work, and we're just going to keep going until, I'll talk about it once we get to that point as to how long do we keep going, right? We got 7, 8, 28. 28 is not divisible by 8, so keep going. 8, 9. 27 is divisible by 9, so that works. 9, 10, 36 does not work. Keep going. 10, 11, 25 doesn't work. 11, 12, 24 is divisible by 12. That works. Essentially, what I'm looking for is as soon as this number becomes greater than that number, then I can stop, right? So let's see. So 12, 13, 23 doesn't work. 13, 14, what is that? 22 doesn't work. 14, and you might be able to jump ahead and see exactly where it'll work, but I'm just going through this methodically. Like in case you want to do this, we also want to see how much time it takes, right? So 14, 15, 20 doesn't work. 15, 16, sorry, this is 21. 20 doesn't work. 16, 17, 19 doesn't work. 17, 18, and then 17. That also 17 and 18, sorry, 18. Yeah, this is 18. Yeah, this works because 18 is divisible by 18, right? So, and I know that if I go to 18, this becomes 19. This will become 17. This becomes smaller than that. So we can stop here. We don't have to go further from this point. So the number of ticks, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, and 7. So 7 options work. So the answer is D. All right, let's look at question 23. So how many 4-digit numbers have all of these 3 properties? The 10th digit and the 1st digit are both 9s. So 9, 9. The number is 1 less than a perfect square, right? So if I add 1 to this, I'm going to get something that ends in 2 zeros. The number is a product of exactly 2 prime numbers. So this number is the product of prime 1 and prime 2. And because it ends in 9, we know that the numbers, this prime 1 and prime 2, either is going to be, the units digit is going to be either 1 and 9, 3 and 3, or 7 and 7. Right? So we got this, we got this, we got this. These are the 3 options. Now, let's see how to use this, criteria number 1 gave us this, criteria number 2 gave us this. Now let's see how to use criteria number 3, which is a number is 1 less than a perfect square, right? Usually what I do is when I see something like this, I try to immediately represent that using algebra. So let's say the number we are talking about is n, and the perfect square is k squared. K is some number, right? So then n equals k squared minus 1, right? Which means I can factor that. This is k plus 1 times k minus 1. So my number n, this number n, has to be a product of 2 numbers that are separated by 2, right? You see that k plus 1, k minus 1. To give you an example, if k is 4, then this would be 5 times 3, right? So I'm looking for 2 numbers that differ by 2, right? Which means I cannot have 3 times 3. Because if my units digit is 3, then both the numbers cannot differ by 2, right? Same with 7 times 7. I cannot have that. So which tells me that I'm pretty much looking at 1 times 9 as my units digit product, right? Now all I need to see is which combinations make sense, because it's a 4-digit number, so it has to be less than 100. The numbers have to be less than 100, right? So one example that could work, where I have 2 numbers differing by 2 and ending in 1 and 9, is 89 times 91, right? It ends in 1, it ends in 9, and they differ by 2. But this won't work because I know that 91 is not a prime number. That's 7 times 13, right? I need it to be a product of exactly 2 prime numbers. So I know that won't work. So now all I have to do is just keep going down the order and see which one works. And you can do that mentally, but I'm just going to write it out. And then 79 times 81. 81 is not prime, so it won't work. 69 times 71. This is not prime, so that won't work. So keep going. 59 times 61. Both of them are prime, so let's see if it satisfies the other criteria. So the way I'm going to multiply is that I'm going to do 60 times 61 minus 1 times 61. So 6, 3, 3660, right? 36, 3660 minus 61, which is 3599, right? Ends in 2 nines. It satisfies that. If I add 1 to it, it becomes 3600, which is a perfect square. It's 60 squared, right? So it satisfies all the criteria. So this works. So let's keep going down. 49 times 51, neither of them is prime, so it won't work. 39 times 41, 39 is not prime. 29 times 31, they're both primes, but if you multiply them, you don't get a 4-digit number because this is less than 30. So if you multiply 31 by 30, you essentially get 930, right? Which is a 3-digit number. So if you use 29, you're going to get a number which is even less, right? So we can actually stop here because once we reach 29 times 31, we are getting into the 3-digit number zone, but we need a 4-digit number. So this is the only option that is working. So the answer is B for 23. Okay. So trapezoid ABCD, we got B and C measures 60 degrees, AB is equal to DC, and the side lengths are all positive integers. Very important point. They're all obviously can be negative, but the important thing is they're integers, right? They can be decimal or fractions. And the perimeter is 30. How many non-congruent trapezoids satisfy all of these conditions? Right? How many non-congruent trapezoids, how many distinct trapezoids, right? So typically, this is an isosceles trapezoid because both these angles are 60. So, in geometry problems, like to draw some lines and write some variables. So I'm going to just, draw a vertical line like this, okay? Because this makes it into a 30, 60, 90 triangle, both of these, right? I like that. And then I'm going to use some variables. So call these x. In fact, let's call it 2x. The reason being, because a 30, 60, 90 triangle, it lets us figure out that, okay, this is going to be half the hypotenuse, which is going to be x, right? If I consider this to be x, I would have to say this is x over 2, and then I have to deal with fractions. So I don't like to deal with fractions. So I called it 2x. And this is x, right? This is x. Now I have no idea what this would be, so let me call that y. And then I'm going to frame the equation for the perimeter, right? Perimeter of the trapezoid is y plus 2x plus x plus y. And I'm guessing you're not going to write all of these to figure it out. You can very quickly visually see that the perimeter is going to be 6x plus 2y, right? And that is equal to 30. Now I can divide by 2, and that gives me 3x plus y equals 15. Okay. Now this is one equation. Now keep in mind that x and y are integers, which means if I write it this way, x equals 15 minus y over 3, right? That tells me that 15 minus y has to be divisible by 3. Now be careful, I have 2x here, right? I have 2x, and I got 2x's here. So even if I get x equals, let's say, half or 3/2, that would be fine, right? But it'll be hard for me to get a number 3/2 when x is 15 minus y divided by 3, right? Something divided by 3 and getting a half in the or 2 in the denominator is going to be impossible, right? Because that would mean that 15 minus y will have to be, what will that have to be? It'll have to be something like 3/2, right? For 15 minus y to be 3/2, or 7/2 or something like that, y cannot be an integer. But we know that y has to be an integer because this is one of the sides, right? So then all I'm looking for is any value of y where 15 minus y is exactly divisible by 3, right? Now think about this. What are the numbers less than 15 that are divisible by 3? It's 12, 9, 6, and 3. Well, 0 also, but again, can be 0. And x can be 0, so no need to worry about that. So using integer values of y, I can get to 12, I can get to 9, I can get to 6, and I can get to 3, right? All of these numbers are possible. Can be 15 again, because for that y will have to be 0, so that won't make sense, right? So then all I'm looking for is these are the 4 options that'll work, right? So that gives us 4 choices. So the answer for 24 is E. All right, 25, very interesting question. At the onset, it seems like a very long question. But let's read. Michaela finds all the possible ways to draw a path in a 5x5 diamond-shaped grid. Each path starts at the bottom of the grid and ends at the top, always moving 1 unit northeast, this is northeast, or northwest. Okay? And she computes the area of the region between each path and the right side of the grid. 2 examples are shown. Right? For example, here, if this is my path, the dark black line, then the area enclosed is like 9 plus 2, 11 squares, right? Here, the area is 13 squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? The question is, if you take all the paths, all the possible paths, and add up the areas, what are you going to get? What is the sum, right? Now, here's the major clue. The question cannot possibly expect us to draw all paths, calculate the area, and add them. Right? That's going to be too tedious, and they know that it's not a practical thing to do. So that's clue number 1, right? Now, I'm going to give you a clue number 2. I'm not going to explain it very well. I would like you to pause the video and think about this clue, how that could be impactful here. Okay, the clue is symmetry. So I want you to think about how can we use symmetry here and figure a few things out, or figure a solution strategy out, right? So pause the video and think about what could I mean by symmetry. I'm being not very clear on purpose because I want you to use that clue and see what you can come up with. Okay, so hopefully you all thought about, what could symmetry play here? What role could symmetry play? But before we go there, I did want to explain one concept which may or may not be known to, I know some of our students know this, but if you're, some of you may not, right? So if I want to figure out in this type of a grid where you can either go this way or that way, how many total paths there are? How many total paths? there are. This is a very easy way to do it. You have to know combinatorics for that. So think about this. If I go from point A to point B, right? No matter how you go, you're going to have to go five squares on this side and 5 squares on that side, no matter how you go. Let's count this one, right? I'm going to count the northeast with a green, and I'm going to count the, what is that, northwest with a red. Okay, so 1, 2, 3, sorry, I need to do green. So 1, 2, 3, 4, 5, and 1, sorry, I need red. One, 2, 3, 4, 5. So no matter how you do the path, you will have to move 5 squares on the green direction and 5 squares on the red direction, no matter how you do the path. So essentially, the answer to this question becomes, hey, I have 10 total steps that I take, right? 5 in this direction, 5 in that direction. Okay. And let's say I have those 10 steps as here, 3, 4, 5, 6, 7, 8, 9, 10. Now let's call this movement right. Let's call this movement left. So 5 of them have to be red. Doesn't matter which 5. And 5 of them have to be right, left and right, right? Doesn't matter which 5 are right, which 5 are left. It doesn't matter. Essentially what I'm saying then is I have 10 total steps. Out of those, I need to pick which 5 are going to be right. Okay, once I pick the right paths, then the remaining ones have to be left, right? So essentially total paths is 10 choose 5. If you don't know combinatorics, don't worry about it. You'll learn this later, right? So 10 choose 5 is essentially 10 factorial divided by 5 factorial, which is 6, 7, 8, 9, 10 over 120. So 10, 2, 4. So that becomes 28 times 9, which is 280 minus 28, which is 252. Right? 252. Yeah, I think that's right. Okay. So essentially, total paths that I have is 252. Let me make sure I got this correct. 6, 7, 8, 9, 10 divided by 120. So 624, 28 times 9. Yeah, 252. Okay, that makes sense. Now let's talk about what I mean by what I meant by symmetry. Right? Think about. Let's look at this. So this gives me an area of 11, right? This gives me an area of 11. And the total area is 25, right? Because I have 5 this way, 5 that way, total area is 25, okay? That means the remaining area is 14. Okay? Now let's try and draw a path such that we get an area of 14. So 14 will have to look something like this. So if I do okay, if I have this, and then it is an L shaped. Okay, so let me draw the L shape first. This, then it goes 3, 4. Okay, I think that should be 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah. So this path gives me an area of 14. Okay. So the path goes like this. Essentially go here, 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 here. Right? This yellow highlighted portion is my path. And the area that I cover in that path is 14. So the way symmetry comes in is for any possible area, you will find a complementary area that'll add up to 25. Okay, because of the symmetry of this shape, you got 5 by 5. You know, these two are they sort of add up to 25. So no matter what path you take, it is possible to find a complementary area that adds up to 25. So 11 and 14. So the other picture that was given to us has an area of 13. So for every path that has an area of 13, I can find a path that has an area of 12. Okay, so if I essentially take all my paths and put it in like two different columns of a table such that the addition is 25, I can do that because of symmetry, right? Because of symmetry, which means if I take my total paths, divide by 2, and let's say this number is n, and I write n here, right? I'm essentially looking at those combinations of paths that add up to 25. Okay, because they appear together. They call it like, you know, they're joined together by the hip, right? Like Siamese twins. So that is essentially the concept that simplifies this problem a lot. So what I'm going to do is, I know the total path is 252. Okay, divide that by 2. That gives me 126. Okay, so there are 126 pairs that add up to 22. Sorry, 25. That add up to 25. There are 126 pairs of paths that add up to 25, which means my answer essentially is 126 times 25. $3,150. It's a little bit of a challenging problem to visualize and see that, but what I suggest is, you know, when you get a question like this, which at the onset seems complicated because our first gut reaction is, let's try to find all the paths, find the areas, and then add them together. It's going to be very long. So immediately stop yourself, because, hey, you know, that's probably going to take a lot of time. We won't be able to get that in the time that is given to us. So why not stop, take a step back, and see if you can find some hypothesis about a simple solution, like something like this, right? In some cases, we will be able to solve it. Some cases, we won't, right? But what we know is that the long path will not be possible anyway, because we don't have that much time, right? So I hope you all enjoyed looking at this video. Again, as I said before, there is always more than one way of solving a problem. If any of you have a better solution to any of these, please post either the solution or the link to the solution, and we would love to look at that. Thank you for listening.